Good morning to everyone. So today we will start the topic electromagnet. Okay. So you all are familiar with the word electromagnet, and you have studied also in your last class 6, that what is electromagnet. Electromagnet means the word electric, and magnet means the magnetic property due to the electricity. So what is actually an electromagnet and how we make an electromagnet? Like this. See, suppose this is iron core, okay? And what we do, we wound insulated wire through it and connect this wire to a power source, okay? So this is called solenoid, and this iron core inside the solenoid is called electromagnet. As the current flows inside in the wires, what happened? This iron core inside the solenoid iron core behave like a magnet, and this is called electromagnet because magnetic properties due to the electricity or due to the current flowing in the wires. Okay. Now, this electromagnet is temporary magnet. Why it is temporary magnet? Because it behave like a magnet only when there is a current or there is a battery. Okay. This magnetic property loses, means this electromagnet or this arrangement lose its magnetic properties. As it is, we switch off the light or we just remove the battery. So what happened? It will again behave like a normal iron core or normal magnetic material. Okay. So what happened? This is temporary magnet. So we can say electromagnet is temporary magnet. Temporary magnet. Okay, so there is an experiment given in your book on page number 119. Okay, now we will discuss this experiment and we will conclude few of the points. So you can see the figure is given like this. Take a U-shaped soft iron core. Make a coil of 20 turns. You have to make a coil of 20 turns like this. Okay. Now you have to connect this wire with a battery and switch. In the next unit 7.2, you will discuss. In the next unit in 7.2, we will discuss about the symbols of cell, battery, and switch. So you can see here, this is the symbol of battery. Okay. This long bar is positive terminal and small bar is negative terminal, and this is switch symbol. Okay. Now, closed circuit. Closed circuit means switch on. Okay, closed circuit means switch on, means current will flow, and open circuit means switch off. Switch off. Okay, so closed circuit means switch on, open circuit means switch off. Just you can see here, this wire is broken, means this circuit is not closed. This circuit is open, as you have discussed in the mathematics, closed figure and open figure. Okay, so the circuit is open, means the current will not flow. So this is switch off condition. Now again we are coming on the point. So what happened as we on the switch? What happened? Circuit is closed. Means closed circuit means switch on condition. As we switch on it. So what happened? Current will flow, and as the current will flow through it, what happened? This soft iron core will behave like a magnet, and this is called electromagnet. Okay. Now when you bring some iron pin or iron needle, something like this magnetic material, what happens? You will observe that this soft iron core will attract the magnetic material, and this proves that it is a magnet. And which magnet? Electromagnet. And electromagnet is temporary magnet. Now remove the wire from a battery. As we remove the wire from a battery, what happened? The condition will be open circuit and switch off condition. No current will flow. So what happened? The attracted pin towards this electromagnet will fall down, because now it is no more magnet. So it proves that as the current flows, it behave like a magnet. As the current off, or as the switch off, what happened? It will again behave like a soft iron core, or we can say normal material. Okay, there will be no more magnetic properties in this soft iron core. Now it has been found that if we increase the current, how can we increase the current? Suppose initially we have connected one battery. Now we connect two batteries like this. So what happened? Due to two batteries, the amount of current will increase. If we connect three batteries, the more current will flow. So we have observed that. Just change your name, Realme 8i. Just change your name. Okay. So as we increase the amount of current, what happened? We have observed that its magnetic strength increases. So as current increases, magnetic strength increases. Magnetic power or magnetic strength increases. And how we have observed this? Suppose we have put a iron needle, okay, here at point P, when we have connected only one battery, okay, and just wait for a 2 minutes, then I will take a doubts. Okay, Kritika Singh, and you change your name. What is written Realme 8i? You just change your name and log in with your real name. Okay. So what we have observed that if we have connected single battery and the iron needle is put at point P, so this electromagnet does not attract at the iron needle at point P. As we have connected two batteries, what happened? The amount of current increases. Magnetic power of this electromagnet increases. So we have observed that the needle which is put at point P is now attracted towards this electromagnet. So we have concluded that as the amount of current increases, magnetic strength increases. Yes, Ayushi Mishra. What is your doubt? Ayushi Mishra. Any doubt?
Sir, what is insulated coil?
Sorry?
Sir, what is insulated coil?
Insulated coil. See, every wire you see in your house is inside copper, means conductor, and outside is plastic covered, that is insulated. Insulated does not conduct electricity. The plastic covering is called insulated. Did you get it?
Yes, sir.
Okay.
Thank you, sir.
Okay, Satyam Tiwari.
Sir, what is the difference between electromagnet and temporary magnet?
See, electromagnet and temporary magnet. Electromagnet is itself a temporary magnet. Temporary magnet means just for a few time it behaves as a magnet. When we switch off the current, what happens? Take a two condition. That is, one, bar magnet, that is permanent. It will always behave like a magnet. But electromagnet will behave like a magnet only and only if current is flowing through it. So that's why it is called temporary magnet. For a temporary, for a few time, whenever a current is flowing, it will behave like a magnet. When current offs, it again behave like a normal iron core. Did you get it?
Yes, sir. Thank you, sir.
Okay, fine. Okay, put your hands down. And now we will take doubts at the end because the class duration is very short. Okay. Now, the first conclusion is that as current increases, magnetic strength increases. Now, what happened when we increase the number of turns? Suppose initially there are 20 turns. Okay. Now, what happened? We have made 40 turns. 40 turns. So what happened? Again, the amount of current will increase because see here only this much area is covered by the wire. So this much current, as we increase the number of turns, the amount of current increases. So it is experimented that as the number of turns, suppose we have bounded like this. There are two conditions. And okay, so here number of turns may be 10 and here 20. So what happened in this case? First case, second case. In second case, when the number of turns increases, the amount of current increases. So here also we have calculated, we have observed that magnetic strength or magnetic power of electromagnet increases. Okay. So the more the number of turns in the coil, the more the powerful electromagnet is. Okay. Now, how to make permanent magnet? So permanent magnet is, there is a given in the book, page number 120, paragraph number 4th. So if we want to make a permanent magnet, electromagnet is temporary magnet, and if you want to make a permanent magnet, means if we don't have any electricity, we don't have any battery, and we want any magnet, so how to make a permanent magnet? So listen, so we need steel or alloy. Alloy, you know, you know about alloy, mixture of two or more metals. So alloy of aluminum, nickel and cobalt is placed in the closed coil carrying current. This is coil, okay, and this coil is carrying current. It is connected to any power source, battery, and we have to put steel all or alloy of Al-Nico, means aluminum, nickel or cobalt. So if we put this material steel or alloy of Al-Nico for a period of time, what happens? This iron core or this material will change into a permanent magnet. So we can make permanent magnet by putting steel or alloy of Al-Nico in current carrying coil, inside the current carrying coil. Now, the permanent magnets find wide application in making magnetic stickers, magnetic coils. Okay, so you all know about the magnetic stickers. So what happened? Suppose this is magnetic stickers type, and it is some figures are given just like any cartoons, Ben 10. Okay, so and backside of there is a magnet, and you can stick on your almirah, this almirah which is made up of iron. So here we can stick. So this is magnetic stickers. Magnetic toys, in childhood we used to play with the magnetic toys, means toy making house. We have to just stick the blocks like this and make a house, make a two-story buildings. So these are magnetic stickers and magnetic toys we used to play in the childhood. And there are two also two magnets like this we used to do like this, throw, and they make a noise. Okay, so that's also a magnetic toys. Now, practical use of electromagnet. They are used in electrical appliances such as electric bulb, we will study electric bell. In electric bell, electromagnet is used, electric fan, and electric motor and generator also. So in these topics we have to discuss in 9th and 10th. Okay, motor and generator. They are used in television for deflecting electron beam in the picture tube. They are used in magnetic separation of iron ores from the earthly substance. This you can understand. Point number 4. What happens in dump yards where there are a lot of garbages and we have to separate the magnetic material, means iron, copper, tin, nickel material from the garbage. So how do we separate? We take a electromagnet. Okay, so connected to a crane. Suppose there is a garbage here. So as we switch on the current, what happened? It will behave like a magnet, and all magnetic material will attract towards it, and we will move the crane other side and switch off the current. So what happened? All the attached material will fall down, and in this way we can separate the magnetic material from the earthly material or garbage and separate from one place to another place. Now they are used for preparing a strong permanent magnet, and we have discussed about alloy of alnico and steel. We used to prepare the strong magnet. Okay, strong and permanent magnet. They are used by the doctors to cure certain disease. Okay, for the treatment of swelling, pain in joints, electromagnet is used. For MRI, okay, electromagnet is used. Now temporary and permanent magnet. So temporary magnet, we have discussed electromagnet is temporary magnet, and permanent magnet, which shows always, it shows properties of magnet always, either due to the current or without current, because permanent magnet does not require any type of current or power source. So let's read the definition of temporary and permanent magnet. The magnet which lose their magnetism or property of magnetism as soon as the cause producing them is removed. Means as soon we remove the cause, means what is the cause? Electricity. As we remove the electricity, what happened? It will lose their magnetism or property of magnet. And permanent magnet, the magnet which does not lose their magnetism when the cause producing them is removed. Okay, because permanent magnet does not require any cause to show the magnetic property. That's why it is permanent magnet. Now electromagnet and its effect. So before 18th century, we thought electricity and magnetism. Okay, Ansh. Yes, Ansh. What happened?
Yes, sir. That what is the means of alnico?
Alnico means alloy of aluminum, nickel, and cobalt. You know alloy, mixture of two or more metals.
Yes, sir. Yes, sir.
Material made up of alloy of aluminum, nickel, and cobalt.
Okay, sir.
Okay, Ira Gupta. Yes. Ira Gupta, any doubt? Okay. This is not responding. Okay, Mukund Singh. You are not responding. I'm allowing you to unmute and you are not unmuting yourself and not replying. We will take doubts after the session. Okay. Or you can ask your doubts in the evening session. Okay. Or you can personally text me for your doubt. Okay. No problem. So discovery of electromagnet give us relation between electricity and magnetism. Okay, now the branch of physics which deal with the relationship between electricity and magnetism is called electromagnetism. Now there is a one important experiment by Oersted to show magnetic effect of current. So what he is doing any experiment. Okay, Okay, so this arrangement you can see in the figure 7.12, that is variable resistance. Variable resistance. Okay, and this is thick copper wire. Thick copper wire. Thick copper wire. Before discussing this experiment, I want to ask you that do you know about the term resistance? Do you know about the term resistance? Anyone? Resistance, hindrance. Out of these two words, you know about resistance or hindrance? Okay, Arshaiman. Okay, tell me.
Sir, which resist electric current in a wire.
Okay, resist. Okay, hinders. Very good. See, resistance, put your hands down, Arsh. So resistance offer resistance, hindrance means they stop the electricity. So take example of fan regulator. Okay, you know about the fan regulator. 1, 2, 3, 4, 5. There are 5. On 5, the fan rotates at very high speed. When you put on 4, speed decreases. When you put on 3, speed decreases. At 1, the speed is lowest. So what happened in the regulator? The regulator is acting like a resistance. Okay, so at 1, there is a more resistance, more hindrance. That's why current will flow very less. So fan speed decreases at the lowest point. So this fan regulator is a type of resistance. So at point 1, what happened? The regulator offers the most resistance, means the most hindrance. That's why the fan runs at a very slow speed at 1 point, and at 5 the regulator offered very less resistance. So what happened? The fan moves at very high speed. So here conclusion that more the resistance, the less the current will flow. Okay, more the resistance, less the current will flow. So here experiment that Oersted is doing some experiment. Okay, this scientist is doing some experiment. He is passing current through a thick copper wire. So during this experiment, there is a magnetic needle kept here. Magnetic needle. Okay, this is the north pole and this is the south pole. And you all know about the direction convention: east, west, north, south. So he observed that during passing the current through this thick copper wire, what happened? This magnetic needle deflect. This magnetic needle deflect. So what happened? He observed that this needle deflect towards this, like this. Means this is magnetic needle, and it deflect like this. Okay. So what he observed that when current flows from south to north, you can see here the current is flowing from south to north. Okay. I'm changing this direction from here. I'm taking this south, north, and this is east, west. There will be no problem. Okay. So when current is flowing towards south to north, we observe the deflection is like this. Okay. So my question is from one of the student that what is the deflection? What is the deflection in this magnetic needle? In which direction it deflects? In which direction? Take this reference for the direction convention and you have to tell me this magnetic needle deflected towards which direction? Okay, anyone? When current is flowing towards south to north direction and this magnetic needle deflects like this. So you have to tell me in which direction the north pole of this magnetic needle goes. Anyone? Okay, Ankita Verma. Yes, Ankita Verma.
Sir, west and east.
West direction. Means the north pole goes towards west or east?
Sir, west.
West direction. Okay.
Thank you,
Fine.
sir.
So You can learn by this formula or rule, snow rule, SNOW. Okay. So when current flowing towards south to north and it is over the magnetic needle, it is over the magnetic needle means, again I am telling you in a simple term, south north, snow rule, SNOW. Okay, listen carefully, it will be easy to learn you, it is not difficult. Okay, snow rule, when current flowing from south to north and this wire is over the needle, so the deflection of north pole of north pole of magnetic needle is towards the west direction. You can see current is flowing towards south to north. Okay, what happened? The north pole of magnetic needle deflect towards the west. As we decrease the resistance, what happened? Amount of current increases. As the amount of current increases, the deflection will be more, and finally it will reaches to the like this full west direction, means perpendicular. This needle will be like this. Okay. So by snow rule, we can see that, and you can reverse when north to south, the deflection will be towards east. So for now, you just revise this thing, Oersted experiment, and when you reverse the polarity of battery, means here plus minus. Suppose this is plus minus, and if we reverse the polarity of battery also, the direction of deflection will also change. Okay, and when we put the wire below the magnetic needle, what happened? Again, the deflection will be changed. In which two cases the deflection will change? When we put the wires below it or when we reverse the polarity of the battery. For now, thank you. Bye. Take care.